I've been in the plastics industry 35 years. Doug mentioned 20 years. That's just how long I've been doing this gig. But I've been in the plastics industry for 35, and Ulrich and I were comparing some notes. We actually know some of the old warriors in the plastics industry and shared some colleagues. I've been called many things in the last 35 years, more recently things like a garbage man or above ground miner. But today I think appropriate for this is I'll call myself a recovering plastics engineer. I've spent my entire career in the plastics industry. I'm a chemical engineer by training and a plastics engineer. I actually have a PhD in plastics to show you how crazy I am about plastics. And one of the reasons I left the plastics industry, and back up just a little bit ago, 25 years ago, I started the recycle research group for Dow Chemical against a lot of resistance because they said we didn't hire a PhD in plastics to work on garbage. Fortunately, I changed their mind about that. But I couldn't get them to turn it into a business, so I had to leave and start my own company 20 years ago. And I have to say we were both right because it took me 20 years to get to where we are today. So both Dow was right, and I like to think that I'm finally right. So I started this company to make plastics cool again. I got a PhD in plastics because back when I was a young kid, 35 years ago, I was a young kid longer ago than that, plastics were a space-age material. They were like the coolest material on the planet. They were one of the newest materials on the planet. Today we have this love-hate relationship with plastics. And it's not because plastics are a bad material. It's because we don't deal with plastics at the end of their natural life properly. So my mission in life is to make plastics cool again like they were for me 35 years ago. And I hope I can make plastics cool for the rest of you as well. So let me show you how I've been going about doing that for the last 20 plus years now. For me, it's always been about creating a more sustainable plastics industry. Someone asked me earlier today, are you a recycler or are you a plastics company? And I said, well, we're both. Primarily, we're a plastics company. We just happen to make plastics from garbage because it's more sustainable both economically and environmentally. And that's what's been driving me for the past 20 years. For those of you who've seen my TED Talk, I apologize. There'll be some similarities to my TED Talk you'll see in here. But I always like to start with a discussion about your stuff, because we all have a lot of stuff in our lives. And I'd like to ask you to think back when you were just a kid, how you thought about the stuff in your life. We have something in the US called the Toddler Rules. This also gives me an excuse to get my children in the presentation. This is my son, who's now 8, so this was a few years ago. He's still got 2 or 3 toys in his hand constantly, and they're largely made out of plastic. This is how toddlers view the world. It's my stuff if I saw it first. The entire pile is my stuff if I'm building something. The more stuff that's mine, the better. And of course, it's your stuff if it's broken. Now, after spending 20 years as a garbage man, it's not clear to me that we leave these toddler rules behind as we develop into adults or as countries, quote, develop into developing countries. And let me tell you why I have that perspective. Because each and every day at our facilities around the world, we handle about 1 million pounds of people's discarded stuff. Now, 1 million pounds a day sounds like a lot of stuff. And for those of you going to see our factory tomorrow, you'll see a lot of dead stuff. But it's just a drop in the bucket of how much stuff gets discarded around the world each and every year. The United Nations estimates there's about 85 billion pounds of end-of-life electronics waste disposed of around the year, and that's one of the most rapidly growing portions of our waste stream. And if you add in other durable goods like automobiles and large appliances and so forth, that number well more than doubles. And of course, since we're here at Plasticity today, I normally just talk about durable goods because that's been our focus until recently. We also have to talk about packaging. And let me put packaging plastics in perspective. This is from the EU. In fact, it's produced by Plastics Europe. This is the breakdown of where plastics are used in Europe. And Europe produces about 40 or consumes about 46 million tons of plastics each and every year. The entire world consumes about 280 million tons. That's over 500 billion pounds for people that are more comfortable with pounds. Each and every year, consumed around the world each every year. And most of it is used in packaging. Other applications include your lawn furniture, the stuff sitting on your desk, accessories, waste baskets, and so forth. And only a small portion actually goes into automotive and electrical, the streams that we have predominantly focused on until recently. But because it's such a large number up there under packaging and others, we've now moved into that area, and I'll talk about that. Now, when this stuff reaches its end of life, it usually ends up looking perhaps like this. And when most people see piles of end-of-life stuff like this, they think of garbage. When we see this stuff, we think of above-ground mines. And the reason we think of above-ground mines is because a lot of valuable materials went into making all this stuff in the first place. And not only valuable materials, but a lot of energy went in to making this stuff. So you can look at this stuff not only as valuable materials, but as embedded energy sitting there for recovery or harvesting. And as we know, the world is developing rapidly, the world's growing rapidly, but more importantly, the affluence of the world is growing very rapidly, particularly in places like next door in China or in India and the developing world. They want the same toys and the same stuff those of us in the Western world take for granted, and there's no reason why they shouldn't have the same toys and the same stuff. To make all those toys and stuff that we take for granted each and every day requires resources. And the world is now going to more extreme means to mine the mineral resources and more deeper mountains and mines and more remote locations to get the metals and minerals that we need to make our products. And there's a lot of talk about rare earth and critical materials. And for the oils that most plastics are made from today, other than plastics like NGO, we go to ever more remote locations to extract petrochemicals, even though plastics only account for a very small part of the petrochemicals, as Ulrich pointed out. Most plastics today are still made from petrochemicals. These types of practices have both environmental and economic implications that we're already seeing today. I think many of us remember the rapid rise in commodity prices, and they actually haven't come down that much, even though the economy cooled. And it's those commodity prices are going right back through the roof again as the economies around the world continue to grow. The good news is, in developing countries in particular, and I would say even in China, a large infrastructure has grown to harvest end-of-life materials from end-of-life products, particularly from durable goods and particularly the metals. These are large shredding operations, and you can find these pretty much around the world these days, harvesting metals from our end-of-life stuff. And the amount of metals recycled are typically well over 90%, particularly if they find their way to a recycler. The plastics are a completely different story. Now, most people think plastics are not recovered at a very high rate because it's a throwaway material, it's a low-value material. But if you compare, and I'm using steel as a proxy for metals here because we all kind of know steel, but if we compare plastics to steel on a value basis, plastics are actually much more valuable on average than steel on a price per pound basis. So it's not because it's a low-value material that the recycle rate is so low. And in fact, now there's more plastics consumed in the world each and every year on a volume basis than there is steel. So it's highly plentiful, it's valuable. Why in the world, if there's so much of it and it's so doggone valuable, why is that recycle bar so low for plastics? Well, the simple answer is it's not very easy to recycle plastics. Let me tell you in very simple terms why it's difficult, or one of the reasons why it's difficult. If you look at metals vary from one another by density substantially. And by the way, let me back up just a little bit, and I think even Steve mentioned it. Plastics, like metals, need to be separated and in pure form if you're going to reuse them again for high quality applications. Metals, it's fairly easy just by density to separate different metals from one another. They have different electrical and magnetic properties which are exploited, and different metals have different colors. So it's very easy for machines and humans to separate different metals from one another. Plastics, on the other hand, have overlapping densities over a very narrow density range. Their electrical and magnetic properties are either non-existent or essentially identical, and any plastic can be any color. So all the traditional techniques used to separate materials from one another by mining companies, by recyclers, simply don't work for plastics. So we had to get real creative and actually invent new separation technologies in order to separate these different plastics from one another. One of the consequences of metals being easy to sort by humans and plastics being very difficult to sort by humans is that some of those of us in the developing world, particularly the United States, export our difficult to recycle stuff to developing parts of the world where labor is inexpensive. And those laborers, paid sometimes as little as a few dollars a day, sort through our end-of-life stuff to get the stuff that a human can sort by hand, just as we heard from the previous speakers. So metals are quite easy to recycle by hand. The glass tubes you see here and many of the plastics are very difficult for a human being to separate, so they end up disposed of improperly. And I could show you hundreds and hundreds of these photos, but you can imagine if a human or simple technologies can't sort it, there's just simply no means in many parts of the world, but yet we continue to dump our garbage in many parts of the world. I call it environmental arbitrage. A little bit more sophisticated approaches are burn houses, and you can actually find these in China and other parts of the world, where inside they're burning away mostly the plastics in order to get to the metals, and then the metals are sorted out by hand afterwards because they have so much value, particularly the copper and the precious metals. Now these practices are not sustainable in any way of thinking about it. It's not safe, it's not fair, and it simply can't go on. And thankfully, developing countries like China have finally said enough is enough. And Doug alluded to the green fence. These types of practices are getting much more difficult to be carried out in many parts of the world. They're not eradicated yet, and they have a long way to go to eradicating them, but they are starting to do that. And it's not trying to put these poor people out of business that are trying to earn a living. We're trying to protect them from themselves because they don't know how nasty these materials are and they don't know the consequences of their behaviors. They're just trying to earn a living. Another consequence of people not being able to recycle plastics easily is that a lot of it ends up being disposed of improperly, even just from natural waste streams. And we find them in freshwater streams, as Doug talked about in his opening remarks. They eventually find their way into oceans. And I think we all know, so I won't spend a lot of photos on this, we all know what happens once they end up in oceans. Here's a graphic from Switzerland. This is the Zurich Museum of Design that tries to put in perspective how much plastic we're dumping in our oceans each and every year. You can see a person standing over there on the left. So this is quite a bit of plastic waste. This is how much they estimate enters our oceans every 15 seconds. Every 15 seconds. So the oceans have become a dumping ground. And there's consequences to that behavior that I think many of us in the room know about. And Doug has done a great job, Doug and many of his colleagues, of pointing out these problems to the rest of the world. So I get asked a lot, well, okay, you've got this great technology and some of these plastics are concentrated on shores and so forth. Can't you recover them? Why can't we just go pick this stuff up? And to some extent, I think we can. But as I said before, it's not easy. So here's a fellow, and I think this is a picture I snapped or I borrowed from Doug. I don't know where you got it, Doug, but I love this picture. So this guy, there's actually water somewhere under that boat, although it's hard to see for all the trash. He's picking something out of that debris, and I don't know if you can look behind him to see what he's picking out. We heard a little bit, there was a need for straws. Well, there's your straws. Now, I thought he was picking them out because all those straws are predominantly made out of one type of plastic so they can be recycled. Someone else pointed out to me, well, there's probably even a higher form. They're probably being reused instead of recycled, which in one context is good because reuse is better than recycling, but in another context, I'm not so sure. I want to use straws that have been fished out of this debris. I show this picture because this fellow's doing the best job he can. If you put me on the end of that boat, I have a PhD in plastics. I can't do much better. It is really difficult to separate different plastics just by humans, by sight and feel, except for things like PET bottles, which are easily recognizable by humans and machines. So indeed, there's whole cities that have sprung up in places like China that their whole mission in life is to recycle as much of the world's plastic as possible. And there's quite a few of them here in China. These photos are from, I believe, from Ningbo, but I'm actually not sure. And what these communities do is the same thing the rest of us do. They can recycle the things that easily, either, in this case, humans can pull out. So PET bottles, you can see there's quite a few PET bottles here, or polyethylene bottles. And it's done on a fairly large scale regionally. But yet there's a lot of plastics that don't get recycled, again, because a human can't sort out what it is well enough. In India, I don't mean to be picking on China, but it seemed like I should show some pictures of China. I'm not picking on China. China actually does a fantastic job of recycling. It's just that not everything gets recycled, and some of that stuff that doesn't get recycled ends up being disposed of improperly. This is a picture I took standing on one of the biggest slums in the world in Mumbai, India. I'm standing on the rooftops looking over that slums, and on top of the rooftops, and I could again show you hundreds of pictures of this, they were storing plastic waste and plastic debris. They bring that down into their workshops, and they sort it out to the best of their abilities by feel, by sound, by color, by shape, and try to sort it out plastic by plastic. But it's very limited to what they're able to do with this, both from a scale and quality standpoint. Sometimes they'll resort to what's the burn and sniff technique. And this is how it works. This was a young lady that demonstrated it for me in Ningbo, China a few months ago. But I, again, could show you hundreds of these photos because this is a traditional way of identifying plastics. So you light a small piece of plastic on fire or a large piece. You blow it out, and then you sniff the resulting fumes and smoke, and you are indeed able to roughly identify the type of plastic. Obviously not a sustainable identification technique. And I tried to tell her as such. She goes, oh, no, I don't do this very often. My workers do this mostly. So it's still not a good idea. Please don't do this. These are compact disc recycling in China, at least back in 2003. I haven't been back to visit. So we're trying to get the metal coating and the plastic coating over the metal coating off the CDs to get to the polycarbonate underneath, and also to recover that thin metallic coating. I asked this fellow, the guy running this recycle center, what he does with these spent fluids, which is a nasty caustic bath, and they take it right around that corner right there and dump it in the field. That was his water treatment system. Obviously, again, not sustainable. So these practices, while they are recovering some plastics, leave a lot of debris behind and a lot of waste behind that we end up dealing with, obviously impacting the local ecosystems, which is why China's erected the green fence, but also impacting us, because as Doug pointed out, actually it wasn't Doug, it was another speaker that had pointed out in one of their slides, what goes in the ocean ends up in our food. I love that because it does. It ends up in our food. So it is coming back. It is not out of sight, out of mind. It's coming right back on our dinner plates. So our habits are ending up on the food we eat every day. The good news is, I mentioned, this was actually before the green fence took place. Wenan's another plastic recycling city that China actually cracked down on to try to elevate their practices of recycling. And they actually made it to the TV news, both the China Daily and one of the TV news stations. So they're taking this seriously. So what are we to do about this space-age material? In our minds, it's way too valuable to not reuse again and to waste. So again, 20 years ago, myself and a few people I extracted from my former company started trying to figure out how to crack the nut, how to figure it out, and we did. And now we're doing it on a global scale. So I'd like to take you now through the second part of the story. So the first part of the story was the problem, the challenge, why we need to do it more properly. Now I'm going to show you what we're doing about it on a very large industrial scale. So the traditional way to make plastics is, again, starting with petrochemicals. You need a big petrochemical factory, and then they make these wonderful materials that we use each and every day that you have all over you and on your table and in your home, and provide you with a lot of benefits, believe it or not. We said there's got to be a more sustainable way, so we're going to start on the procurement end, and we're going to start with waste instead of oil because it's more plentiful and it's got a lower cost that's not directly tied to oil. And instead of building a big chemical factory, we're going to do what's called mechanical recycling. We just use air and water and clever mechanical techniques. No chemicals involved to separate the different materials, because all the hard work's been done by those chemical factories. The molecules have been broken down, recombined to make all these different types of plastics. That's been done. All our business is just separating from each other, each type of plastic from one another, and cleaning them up. That gives us a lower capital cost footprint. It means we use 80 to 90% less energy. 80 to 90% less energy. We only require 10 to 20% of the energy compared to making virgin plastics. That's huge. And that's been verified by a Swiss research institute, life cycle analysis, IMPA, did an independent study. It was refereed. So this is a real number. In fact, they came up with a bigger number. I'm being conservative. And we have a more flexible plant. So when you spend $100 million or more dollars to build a plastics plant these days, a virgin plant, it will make one type of plastic for its entire life. Our plastic plants can make any type of plastic we feed it. And finally, we make a drop-in replacement for virgin. We save 1 to 4 tons. In fact, the IMPA study came up with over 4 tons of CO2 for every ton of virgin plastic we replace. We close the loop for our manufacturers, and they're able to make more sustainable products. So I'd like to just take you, I hope many of you can go on the plant tour tomorrow, just over in Guangzhou. If you can't, I'm going to try to give you a visual feeling of what our plant does very quickly in a 90-second video of how we do what we do. So I hope that, there we go. So it all starts off with, typically with other recyclers who handle either garbage companies or metal recyclers. They shred it to recover the metals. What's left over is called shredder residue. It's got some metals, circuit boards, carpeting, foam, wood, glass, rocks, stones, dead animals sometimes, literally, in it. We pick through that using automated technology, size reduction, metal separators, air separators. This is the Willy Wonka part of our factory, I like to say, so it's more of a traditional recycling part of our factory. After this part of the factory, it comes out, and we've got mostly mixed plastics. Now the really difficult part becomes separating all the different plastics. This is done with a very high-tech, many different technologies, many different steps. We also scrub the plastics so they're ultra clean on the surface. And then we separate them by type, by grade, and even by color. And they come out, these haven't been sorted by color yet, but they come out as one flake, one type, one grade of plastic. Those are then blended in 50,000-pound blending silos to make them homogeneous, one type of plastic. We make spaghetti-like strands, just like you would with a virgin plastic, and we chop those into pellets, again, just like you would with a virgin plastic. And we make a direct drop-in replacement for virgin. Our plastics are used on a one-to-one basis, 100% used by our customers for virgin products, or for new products. Our plants, so we've scaled this. It's to do this right. You could imagine you could see that there's a lot of equipment involved. The capital costs are significant, not as much as a virgin chemical plant, but they are quite significant, more than a, let's say, informal recycling, where you're using tanks or people. So these are very large-scale plants. Our first plant was actually in China, the one that many of you will see tomorrow. And we brought that online in 2006. The same year, we brought one on in Austria, and our more recent world-scale plants in the UK. This is what the plant in Guangzhou looks like, that you'll get to tour, some of you at least that make the tour. Our plant in Austria, and our newest plant in the UK. Together, we're processing a capacity of around 350 million pounds a year of plastic, which is a tiny scratch of the surface of how much plastic is produced each year, but it's a start, and it's a big start. So now, instead of your plastics ending up on a hillside in a developing country or up in smoke, they're back on your desktop in these new products. So I'm just going to give you a sampling of some of the products that customers are making from our plastics. All of these are using our plastics at 100%. They're not diluted with virgin or any other materials. Electrolux is one of our big customers. They're so proud of their recycled content. I don't know if that they print it, they mold it. It says 70% recycled plastic. And they were typical, and Doug mentioned brands, so I'm going to spend just a moment on the importance of brands. So Electrolux has done a couple of things. They've made a commitment to using recycled materials in their products. They advertise it proudly right on the product. And they did a program called Vac to the Sea in order to shine a light on the problem with plastics ending up in the ocean. So they've been very proactive and see this as a big marketing advantage to them to be using recycled plastic. It didn't start off easy though. When they first came to us, much like many of the companies that we work with, they said, well, let's try 20% of your plastic mixed with 80% virgin, and let's put it in a hidden part in a part that doesn't matter. And we said, fine, but that's going to cost more money, and don't you want to use more recycled plastic? In less than a year, they got to the 70% mark, and we're in these parts that you can see here, surface appearance parts at 100% our plastic. We're also in coffee makers, so far non-food, not the non-food portion contact or the non-water contact so far. In coffee makers, we're in the new George Clooney Nespresso machine. When they advertise recycled plastics, that's our recycled plastics in that machine. These are printers. I think both of these happen to be HP, but we also sell to Lexmark and some other name brands. This one here, you probably can't tell from the photo, but Ulrich will appreciate that that's a mirror finish, and that's 100% our material. When they came to us and said, we want to make a mirror finish, we said, no way, forget it. You know, all it takes is one tiny little imperfection and the part's rejected, because the mirror finish shows us everything. This is a textured finish, which is a little bit easier to hide minor imperfections. We're talking imperfections that are just perceptible. But we managed to pull this off. This went through a full production cycle, and somehow we managed to make it work. So I'd like to end where I started, and I've got a few videos, by the way, so this isn't the very end, that I'd like to share with you. So your stuff. I hope you think about your stuff a little differently. And I got to get, since I gave my son some airtime, I gave my daughter some airtime. She's now 12, so this was some time ago. But her shirt, if you can't read it, says, "Listen to your mama." My wife says it means her, and I say, no, it's actually Mother Earth is what this is supposed to mean. Anyway, we took our clues from Mother Earth. Mother Earth uses everything, wastes almost nothing, and that's our mission as a company. I hope you stop looking at yourself as a consumer. I hate that label. I hate being called a consumer by companies. We use stuff until it can be used for another purpose. Don't think of yourself as consuming stuff, because that means when you're done with it, you're going to think of it as waste and garbage. It's not. It's a resource that has to be converted for another use. That's how you should view all of your end-of-life stuff. And I'd like to change that last Toddler Rule just a little bit. If it's broken, it's my stuff, all right? So the last thing I'd like to talk to you about is communications. Part of why we're here, and part of what the great group that Doug has assembled around him does, is communicate both the importance of the problem we're facing and solutions to the problem. We're the solutions bit, by the way. So over lunch, we have to do some work. You have to work for your lunch. We're going to try to come up with solutions. And that's what this conference is about, finding solutions and communicating those so other people can help us. There's a lot of resources out there. So I just wanted to spend a little bit of a moment about this. This gives me a little bit of time to brag a little bit on some communications we've done, but the real reason I'm doing this is to tell you about the importance of communication and that social media can be a powerful force in what we're all trying to do. I never believed that. We're a B2B company. We take plastics from large recyclers, we convert it into new plastics, and we sell it back to a business. So a consumer never sees us. They have no idea who we are. It doesn't say MBA Polymers inside, at least not yet. But we didn't, so I thought there was no consumer-facing audience for us. But I gave a TED Talk about 1.5 years ago. In 4 months, there were over 400,000 views. It's over 750,000 views now, just on TED, over 1.5 million web-wide. Who knew that anyone cared about plastics recycling? It's just a talk about plastics recycling. But people are emotional. I get emails still, daily. What can I do to help? Why can't I have one of these in my backyard? I had no idea you could recycle plastics. Where can I buy stuff made out of your product? I tell all of our customers about those emails when I get them. Where can we buy products made with your recycled plastics? So people care. The average person on the street really cares a lot about why we're in this room. So let's enlist them. Let's get them involved. Let's reach out to them and bring them into this discussion. It's up to all of us to do that. TED is one mechanism, other social medias. I also wanted to mention, if you haven't seen it yet, you need to go see this film. Jeremy Irons, so this is another communication, kind of big scale communication. So it's an 1.5 hour documentary featuring Jeremy Irons, the famous British actor, talking about trash and the problems with the way we deal with our end-of-life stuff. It's very touching, and it touches better than I've been able to do in my presentation, much better on some of the issues I've just scratched the surface on. I thought I knew all this stuff, but I teared up at several parts of this movie. It's a very compelling movie. It's sort of like Michael Moore meets BBC or something. So he's a little bit in your face, but also done very professionally. I highly recommend this movie. And the tagline is, if you think waste is someone else's problem, yeah, think again. Out of sight and out of mind just doesn't work anymore. So finally, the last video, I guess there's actually 2 more videos. This is Shift.com. I encourage you to look into this. They're trying to make Shift happen. little play on words there. So SHFT, a shift in thinking. And they created something called the Big Shift in conjunction with Virgin and Ford and Stony Brook Farms to say we have to really think again about how we're living our lives. And they picked 10 innovations around the world to focus on and give so it's a couple of Hollywood folks got together and say we're going to put Hollywood power behind 10 innovators in the world doing important things, because a lot of these innovations in the world just don't have the horsepower to talk about what they're doing. So again, it's about getting the word out. We were lucky enough to be one of the 10 they picked, and I'm going to show you the 3-minute video that they produced to talk about what we're doing.